I'd like to demonstrate on this part one of our options that we have, one of our machining options that we have in SolidCAM called mill turn, as seen over here, as opposed to turn mill. Mill turn is basically we see it as a milling machine, which is also capable of doing lathe work, turning operations. And what we have a little different than we had before, if I were to go into my coordinate system manager, our coordinate system manager is a lot easier to deal with. You don't have to have special coordinate systems that we had for the turn mill. If I have, for example, position 1, I can use position 1 for both turning and also for milling the face. I don't have to have a separate coordinate system for that particular, for the face in milling and turning. I can use the exact same coordinate system. And creating coordinate systems for the rest of my part is just as simple as any milling operation. Also, if I go into my operations itself, I have my add milling and add turning, and each one of those has all the operations. Whether it be milling, has all the possible milling operations, and the turning has all the possible turning operations. Let's take a look at the part itself. What we have to do in this part is, first of all, we obviously have to turn the outside diameter of this part itself. We have to drill the middle. We also have to drill these holes around on the side. That's already a milling operation. Also mill out this area over here. In addition, we also have to mill out this pocket. As you see here, this is on an angle. We have to use to actually position our head according to this particular angle. And we also have to work on this slot pocket over here, which will be simultaneous work. And the same thing with this slot that we have over here. I'm just going to go right now into one of my operations. My first operation, I've done a drilling operation to drill out the center of this part. Simple lathe operation. Let's just go into our edit, and you'll see there's actually a drilling operation within turning. Just like any drilling operation in turning, we have our tool, we have our technology as far as drill start position, drill end position, drill cycle type. Very typical, very simple drilling operation in turning. I do just a quick simulation of that. You can see by using Solid Verify that my tool goes down and drills out the middle like I've told it to do. Now if I go into my second operation, as you see, I'll be turning the outside of the part itself over here. As you can see, this is what I want to do over here. In the operation itself, again, this is our typical turning operation. I've chosen my geometry, which was around the part itself. As you can see, it took this entire area from the beginning until the very end. What's also important to note is the envelope that was created around the part. You see, it's not on the part itself, but rather it takes into consideration the highest point of this area that it has to turn. Of course, I have my tool, my technology, which I'll be doing a rough cut, and I'll also be doing my finish cut. A quick simulation will show exactly what's going on, where the tool is going down, clearing up the outside of the part itself until it finishes and does this entire area as seen here. Operation, I'll be doing a groove cut. Just a quick click over here and you'll see I'll be working in this area and in this groove over here itself. Let's just take a quick look at the operation and you'll see that my geometries in this particular case are these two grooves over here. The first groove with a little extension at the end, and my second groove as seen over here also. The tool is a tool specifically for grooving. In my technology, I'll have my working area, my work type as rough, and the data area I have an offset, and my step over will be going from one side to the next side. Or I can do from the middle to the sides. In this particular case, I'm using side to side. And of course, my finish will be using the turn groove method. If I were to do again a quick simulation of this part, of this operation, you'll see that the tool goes in, clears off that area, and then goes to the next groove and finishes that, doing both grooves within one operation, as seen here. The next three turning operations is simply will be adding a groove inside the part itself. As seen over here, there's a small groove inside. In addition, I've also added another operation to clean out this area over here with an undercut. But let's continue on now past the turning operations, and let's start our next milling operation. Now you'll note when I do my next milling operation, I'm still using the exact same Mac 1, position 1 as I did in the turning. In other words, I do not have to create a specific position, Mac position for the turning. What I've done here is actually work around the outside of this area over here. It's a simple milling operation where I have, as I showed you, my Mac 1 position 1, my geometry, my technology, my upper levels, my profile depth, as shown here, my regular milling technology, my links, approach as a tangent, lead out also as a tangent, and if I were to do my simulation using your solid verify, you'll see that my tool simply will go around this area and would simply mill out the entire area as seen over here. And you'll note that this area over here was not machined because this was actually already finished in the turning of the part itself. And my next operation, I'm basically doing the same thing as I did before, but this time I'll just be doing a finish cut. If I show the simulation on this, you'll see very simply the tool goes down and does the finish cut on the part itself. One cut. Now my next operation, I'm already using, this time I'm using a different Mac position. And what I'll be doing here is working on this pocket here. This Mac position is basically tilted so it can clean out this pocket itself. Let's just take a quick look at the operation itself. You'll see I'm using Mach 1 position 4. My geometry in this case is this area over here, this boundary as you see over here. The tool that I will be using will be a regular end mill, 16mm end mill. My levels, my upper level, is actually taken over here, but I've made it go up a little higher than that. I've written 12mm, and my pocket depth is up until the floor itself. In my technology area, I'll be using a simple contour option of pocket machining, where my link, I can have a lead in, lead out any way I want to have it. And if I just do a simple save and calculate and simulate my operation, again using my solid verify, you'll see that the tool will come down in an angle as seen here. And basically milling out the pocket at the right angle, as seen over here. Now, continuing in my Mach 1 position 4, I still have to drill out this hole inside over here and these 4 holes over here. So in this particular operation, as seen over here, I've gone through the middle, showing my geometry right in the middle of the part. I've used a simple drill of a 20mm drill. My levels, drill depth, drill cycle type, and if I do my simulation, you'll see that my tool will simply drill out the middle of that part itself, of the pocket, as I go down one step at a time. Simply drills it out. Now if I continue on, you'll see that I also continued on boring out this hole over here. And then in my next operation, I dealt with these 4 holes on the side. Here using a simple center drill. If I were to simulate this operation, you'll see that my tool goes in, goes down, and there's a center drill operation on those holes. And obviously my next tool will simply be completing those drilled holes itself. Now my next operation, I've decided to deal with this pocket over here. But this pocket, as you note, does not have a flat bottom floor, but rather it goes along with the arc of the part itself. So therefore this pocket has to be done. We'll use a regular pocket operation or a profile operation if we have a tool that's big enough to cover this area. But what we're going to do is we'll be using a simultaneous 4th axis while doing that operation. If I go into my operation itself, obviously first of all I have to be using a different Mach position, which is, according to this part, this area over here. As you see, it's perpendicular to this surface no matter which way you look at it, which by the way we'll use also later on for this area over here. If I go into my operation itself, now let's take a look at what I've actually done over here. First of all, as far as my geometry goes, it's this area over here. As you see over here, I've taken the bottom of that particular pocket. Let's just go into define for a moment. And you see I have chosen my chain. Another important fact to notice is the fact on the bottom I have this as parallel to X. But one more thing we should also notice, even besides that, is that we also have here, we're using fourth axis. And the coordinate type will be split, working on the YZ plane. In my levels, I have my upper level, and I have my profile depth. And my technology is your typical, simple profile technology, doing a rough cut, doing a finish cut, links. Let me just do a quick simulation. And you'll see when I do my solid verify simulation that the tool will go in. And again, I'll do this one step at a time. And as you see, it works its way around. And then does its finish cut to finish off this slot. What I'd like to do right now is to deal now with these holes over here. For that I have MAC position 1, position 5. And if I were to look at the top view, it's basically, as you can see, these holes over here. Now these holes are actually going straight down. In other words, they're not going around. They're not turning, but it's basically straight down from this angle over here, as you see. So, in my first operation, since this hole is on a different height than these two holes, I've done this separately. And if I go into my operation itself, you'll see I have my MAC 1 position 5. My geometry as shown here as this one hole only. My tool, my levels. A simple simulation will show that my tool just simply goes down and drills out that hole on the side as seen here. Now in my next operations, I'll be using again the same home position, but instead I'll be doing that, what I did on this hole over here, I'll be doing that on these two holes as seen over here. Again, I have my geometry as seen over here. And if I do my simulation using my solid verify simulation, my tool goes down into that area and does both of those holes as seen over here. In my next operation, I'd still like to deal with these three holes over here. So what I can do is I have my MAC position as seen over here, that if I look at my top view, you'll see that this hole is exactly perpendicular to my z-axis, but these holes are not. However, all of these holes are going towards the center. So in my geometry, let's take a look at what I can do over here. Choosing only the center hole will only do that hole, but what I can do is, instead of creating home position for each hole individually, I can choose a new type of geometry, and next to define, you'll note that there's a little arrow over here. If I go into around fourth axis and now click on define, by simply clicking on this surface, I will get all the holes that go towards the center as seen over here. And you can see their exact positions, minus 20 degrees, 0 degrees being the middle one, and 20 degrees. Again, I have my tool, my levels, technology, save and calculate, even though I make a mistake every now and then, simulate, and if I do my solid verify simulation, you'll see that all of these holes are drilled out exactly the way they're supposed to be drilled out within one operation. I now like to deal with this particular slot over here. Again, this slot is also going around the part itself. So again, I'll be using my Mach 1 position 2, just like I've used when I did this area over here. And if I go into my operation, again, my geometry, again, is very simple. The very bottom part of that slot that you see over there. And again, I'll be using the option of fourth axis, as I've done before. My levels, technology, simple, just as in any profile operation. And in my simulation, you'll just simply note that the tool will go down, as seen here, go around, working on that angle, and then basically working its way back, doing that entire slot. Next set of operations, I like to go back and deal with this area over here now. There's still some more things I have to do. I still have all this drilling here to do. Again, I'll have my Mach position 1 and position 1 itself, just like in my drilling, just like in my turning. I can go back and forth, use it whenever I want to, as seen over here. And then I'll use my simple drilling operations. Drilling the first hole over there, the second one, and the next one, as seen over here. All this done, Mach 1, position 1, simple drilling operations. I'll just do a quick simulation of it. And as you'll see in the solid verify, again, the tool will simply go down. I have my center drill, my regular drill, and a tap at the end. Last two operations. In this particular operation here, I'm simply working this area again. I just still have to tap out this hole. What I'm basically showing here is I can go back and forth between every single home position, whichever order I want to do it in. I'm not locked into a specific position. I have to do it one particular way. And I have the same thing with my last operation. My last operation, actually, what I'll be doing is showing that this area over here, I'm going to just do a simple milling operation over here also. Notice I didn't have to do it by turning. I can also do it with a milling operation using a regular end mill, my levels, going down to this level over here, my technology, finish cut, and if I just simulate that particular operation over there, you'll see that my tool will go in and simply work around on that area itself. Now you'll note in my simulation this area over here. That's because the tool I use did not have a that much of a cutting edge on it. So what I can do is I can actually make a little change over here in my levels. In my technology area, I can have my finish step down less. I can say every 15 millimeters. Because my tool itself, if I go into my tool, you'll see that my cutting length is only 24. So by going down 30, which I did before, actually was not able to cut over there, and therefore we got a crash notification during our simulation. But now that I changed it to 15 instead of 20, if I go into my simulation, again, doing my solid verify, you'll see my tool go in, and then finish off cleaning the rest of that area itself. This concludes our lesson of showing you how to demonstrate a part in Multi-Sided. Take care and have a nice day.